Hello everyone. Today I'm going to use a different method to prove the statement that if two lines are perpendicular to each other, then the product of their slopes equals -1. Here we have two lines AB and CD. They are perpendicular to each other. As we know, any lines can be written as slope-intercept form. So, for the line AB, we have slope-intercept form y equals m1 times x plus b1, and line CD has the form y equals m2 times x plus b2. Now, if we will draw a vector u starting from point O and parallels to the line AB, then this vector u should have the same slope as AB, since they are parallel to each other. Then any point on this vector u should have ux equals x1 and uy equals m1 times x1. Similarly, we can draw a vector v starting from point O and parallels to the line CD. So the vector v should have the same slope as the line CD. Then the vx should be x2 and the vy should be m2 times x2. Now we have to use the dot product of two vectors. Vector u dot vector v equals ux times vx plus uy times vy equals x1 times x2 plus m1 times x1 times m2 times x2. However, the dot product of two vectors can also be written as amplitude of vector u times amplitude of vector v times cosine theta. Here, the theta is the angle between these two vectors. As we know, the line AB and CD are perpendicular to each other, and the vector u is parallel to the line AB, and the vector v is parallel to the line CD. So, the cross angle between vector u and vector v should be 90 degrees. Then we get the dot product of u vector and v vector equals 0. Then we can get x1 times x2 plus m1 times m2 times x1 times x2 equals 0. However, the x1 and x2 are any point on the vector u and vector v respectively. So, in order to satisfy this equation at any point x1 and x2, the only way is m1 times m2 equals -1. So, we have shown you 3 ways to prove this statement. This kind of exercise will maximize your knowledge. Thank you for watching.